Neptune was expected to be very similar to Uranus. However, Voyager 2 discovered that it has an internal heat source that makes it emit more than twice the energy it receives from the Sun. This extra energy explains the appearance of Neptune's atmosphere, which has more detail than Uranus or even Saturn. Neptune's atmosphere features bands of various shades, a number of dark ovals, and a variety of cloud formations. The small white cloud at lower left was named the Scooter because it scooted around the planet at great speed. In Neptune's southern hemisphere, there's a huge dark oval feature the size of the Earth. Its similarity to Jupiter's Great Red Spot led to it being named the Great Dark Spot. It's a large high-pressure system. Around the edge of the spot are wispy white clouds that changed rapidly in appearance.
Now, we had some hints from Earth-based observations that Neptune had a few clouds, and at least that was better than Uranus. But we really weren't prepared for the spectacular weather activity that Voyager found. In fact, Neptune is the windiest planet in the solar system, and I was totally unprepared for that.
We had expected, because Neptune is not tipped on its side as a planet, but is an upright planet, that the magnetic field axis would be aligned with the rotation axis. That is, the poles would be near the rotational pole. We were surprised again. The magnetic field is tilted by 47 degrees in the case of Neptune, and its center of the magnetic field is offset by almost 2/3 of the radius of the planet. Its magnetic field is somewhat weaker, only about half of that of Saturn's, for instance, at the surface, and its magnetic field extends only about 400,000 miles from its surface. We did discover that the rotation period of the magnetic field is about 16 hours and 7 minutes, faster than Uranus, but slower than both Jupiter and Saturn.
As we approached Neptune, we were approaching with the Sun and the Earth almost directly behind us, so you could see virtually a full disk of Neptune. And we aimed to go right over the North Pole, right up over the top of Neptune, very, very close to Neptune. The trajectory was then bent by gravity, moved south, and we intercepted Triton while it was behind Neptune and underneath it.
Well, as we got closer and closer to Triton, it got smaller and smaller and smaller, and at the same time brighter and brighter. It turned out to be the brightest thing we've seen in the solar system. North of the polar cap, in the north, just above the equator, we find one thing we call the cantaloupe terrain. It has a system of crisscrossing ridges which produce a set of almost squarish to ovoid dimples throughout the surface. Now we're talking about a surface which is 37 degrees above absolute zero. This is the coldest thing in the solar system by far. Even the cold atmospheres of things like Neptune are warmer. It was unthinkable to find activity going on a planet whose surface temperature is that low. I mean, this is getting down to the point where molecules stop. It was about a month after the Voyager encounter that we were looking at stereo images way down in the southernmost part of Triton's polar cap, and we saw most of the features lined up as if they were on a perfect sphere. In fact, the two best examples turn out to be active eruptions in which material is being blown from the surface in a vertical column to an altitude of 8 kilometers, roughly 5 miles. Voyager discovered 6 new moons at Neptune. 2 of them were found in the ring arc or ring system, orbiting along 2 of the ring arcs. So apparently shepherding the edges of those ring arcs in some way.
When we look at Neptune's ring system, as we can see here in this mosaic, we see three continuous rings quite easily. There is an outer ring. It's the ring in which, in fact, the three arcs are embedded. There's an inner ring which, in high phase geometry, appears brighter than the outer ring. That tells us right away it's dustier than the outer ring. And then we see an inner, more diffuse ring at something like 42,000 kilometers from the center of the planet.